So we're starting with just a reminder of what a tree is. If it's a heads and a tails, those are the outcomes. And then the total sample space. What the heck is that? Would you please talk to the kid next to you? If I said, what was the sample space? Talk to the person next to you about what the answer is. All right, the sample space is all the things that could happen. Heads and tails. Those are the only things that could happen in this so far. That's called the sample space. It's what could happen. All right. So it's just like a list of all of the outcomes. Now we're going to do something different. You're going to use a rigged coin. Have you ever heard of a weighted coin? So let's say that this weighted coin is 60-40 heads. Like head comes up more often. So when you do that flip, your probabilities all of a sudden change, and your final answers for each of these routes would change. So let's put the 6 on the top just to make your life easier, because so all your charts will be the same as each other. And then get the final answer for how the chart should look. Now, after your first coin was a normal coin and the second was a weighted coin, then your final possible results. Isn't this just the tree? No. You're supposed to have the final probability of this right here. Final probability of that right here. Probability of that right here, and probability of that right there. Actually, wait, even more than that. You're supposed to have the sample space in all of those boxes, and then the probabilities after that. What are you talking about? This is heads, heads. This one together was heads, then tails. This one was tails, then heads, and this one was tails, then tails. And then the probabilities after that. Finish up your chart, and then we'll be able to talk about it intelligently. Okay, so you should have then multiplied the routes together, like 0.5 times the 0.6. 5 times 6 is 30, but it's 0.30. And 5 times 4 is 20, 0.20. 5 times 6 is 0.30 again, and then 0.20 again. And when you put them all together, these add up to 1, as in 100%. And this is what's called the sample space. Yes? 0.3 is fine. 0.3, 0.30, either one's okay. In fact, on the test, usually you're going to be asked to give 3 decimal places. And what if the answer is 0.3? I'm fine with that. Or that. For 3 decimal places. Either one would be okay. All right. Well, so what's next? Were these events dependent? Talk to the person next to you, see if you agree. Were they dependent? Okay. I get how this could be confusing, but I would ask yourself, does this depend on that? So, does what happens in this coin flip depend on what happened there? No, it does not. Coins are not going to affect each other. If I flip this coin, this other coin, it doesn't care what I got the first time. They're separate coins. Those are independent. How about a deck of cards? It depends on how you do the deck of cards. Do you get that there's 52 cards in a deck? Okay, and if you didn't know that, if we give you a deck of cards question, we have to include what is in the deck of cards, so you'd know that there's 52 cards. If I had the probability of getting a red one, and then getting a black one, does it depend on what I got the first time?
I have a question.
Wait. Does it matter what I got the first time when I drew? Well, it matters whether or not I replaced the card.
Yes.
Okay, so if I replace the card and it's a fresh deck again, now does it matter? What I got the first time? No. So then, whether it's dependent depends on whether you put it back in or not. All right. So next thing I want to talk about is, let's go back to this chart here. What was the probability that you got at least one heads? At least one. Out of the two flips, at least one. How'd you get the 80%? You are correct.
What? 0.3, 0.2, 0.3 together because they all had.
Because this or this would make you win. And what did I say about or? That you'd add them. Or things tend to add together. All right. And remember about or being a big answer? You know, like I said, raise your hand if you have a dog or a cat or have hair. All of a sudden, everybody's raising their hand. Or's big answers. So this was, I could win if I had heads, heads, or heads, tails, or tails, heads. All right. Okay, next one is here. Given that I got a tails on the first flip, given tails on first flip, what's the probability of tails, tails? Now you might think it's right there, Mr. Server. Nope. It's not 0.2. Given that it was tails on the first flip. Don't say it, please. If you have a question, you can ask me a question. Don't just say the answer. Okay. Got to give people time. Given it was tails on the first flip, figure out the probability of tails, then tails. All right. Write down what you think it is. Talk to the kid next to you.
Because the tails percentage is 0.5.
And I totally get why some kids were thinking, well, then it's just a 50-50 chance. But the second coin flip isn't 50-50. That cell phone goes on the phone jail. You can't have it out. You are addicted to your phone. I've noticed it before. Got to get over it. Okay, so this one comes down to this right here. Because see, after you've gone through this route, this is the route we're talking about. And I'll draw it with this highlighter. We've already done this, so that's a given. Okay, now what's the probability we're going to go here? And it's that 0.4 right there. Raise your hand if you had 0.4. Okay, good. All right. So there's a lot about trees. What else do you think there's a lot about we've done for the last couple of days? Diagrams, the Venn diagram. All right, so let's make a Venn diagram. And let's all make this A and B and C. And it's going to be apples, bananas, and carrots, just to keep life simple. My question is, if I said we polled 100 people, where would you put that? Know where to put it? Outside of it. And I personally put it in the upper left here. 100 people were polled. Okay. Now, what if I said 30 people liked apples? What can you tell me about that? Not much. You're right. Because I didn't tell you where to put it exactly. I said apples. But if you thought you'd put it here, you would be wrong. Okay. So you could make a little blank in each of these spots. And one on the outside of all of those spots were the people that didn't like apples, bananas, or carrots. If I said apple and 30, where should you put it? Right next to the apple. Those are going to add up to 30. All right. Now we're going to put in a whole bunch of numbers. Okay, so just pay attention and put them in the right spots. 10, 10, 5, 5. Do you agree that that is a possible outcome? Okay. Next, let's say that there's 20 people that didn't like or didn't want apples, bananas, or carrots when they were handing out the veggies and fruits and stuff. Now, I'm going to tell you something that will help you to figure out what things go where at the end. All right? The people who like bananas and carrots, did you get that that meant and? Did you know that that symbol meant and? I hope so. Bananas and carrots was 10. The people who liked bananas just a second here. Was 30. I think you can figure out the rest. This is one of the hardest things though, so I totally understand you're going to want to talk to the kid next to you, see if you did it right. I'll pause for a second to see if you can talk to the kid next to you, figure out where those last 3 blanks end up being. Okay, there's a really common misconception. People put this 10 in that blank right there. But together, these make 10. So you should have put a 5 in that blank right there. Then, if bananas is 30, I can put that here, and all of these have to add up to 30. So then 10, the 2 5s make another 10, that's 20, so this must be a 10, that makes 30. All right. And then I can use what magic number to figure out this? What's the number you'd have to use to figure out that? There's only one spot left. And they add up to 100. That's the number that you'd use. You take 100 and you subtract off all the other ones. What is 100 minus 10 minus 10 minus 10 minus 15 minus 20? 35. Who had a 35 there?
I changed it.
All right. You guys what I did there? Okay. So, now that I've made this, I'm going to ask you a question about it. You have a question about why something's what?
Did you add the 20 to the, when you added them all?
I think that if you right now add up all the numbers I have, it should add up to 100. Maybe it doesn't add up to 100.
It does.
Okay. 45, 50. I think it adds up to 100. Just add up all of these numbers. Not these. You can't add up those numbers. They're not in the chart. They're just numbers that were helping us. Okay. All right. So then here's some questions about this chart. A very typical question would be, what is B union C? And I'm going to make it a probability. Remember, it's out of 100 then. What's the probability of B union C? And then, might as well at the same time figure out B intersect C, because you need to know the difference, of course. Figure out those 2 answers. And it's a probability, so you could write it as a decimal. The answer is going to be in 3 decimal places. Okay, I'm hearing some good conversations. People are talking about ors and ands. This is an or. Doesn't that tell you it's a pretty big answer? Yeah. All right. And this is an A, and that's like an N, and then a D. That's an and. And remember, those are small answers. What's the probability you have a dog and a cat and a electric hairdryer? Okay, the probability keeps going down. This one's big. And so then I look at the B and the C, and I put them all together. Everything that's in B and everything that's in C. So that would be 10, 20, 30, 35, 65, 70, I think. Raise your hand if you had 70 out of 100. Excellent. That would be 0.7. Or if you wanted to go 3 places, just put in a 0, 0. No, I wouldn't mark it wrong because 0.7 is fine. Okay, how about intersect? Well, that's the 10 out of 100, which is 0.1 or 0.100. Make sense to you? All right, then they get more complicated. Now I'm going to say, given the person liked apples, what's the probability they also liked carrots? Given they liked, I'll write it down. Given they liked apples, what's the probability they also liked carrots? Now remember that given changes it and it won't be out of 100. If you did stuff out of 100, you did it wrong. Because when they say given, they're changing it. They're saying it's not out of all the people. So if you thought it was out of 100, you're doing it wrong. Given they like apples, what's the probability they also like carrots? All right, talk to the kid next to you what you think it is, see what they think it is. Okay, I find it's handy to come back to this. It's what you want out of what's possible. And I heard a lot of people saying it was out of 30. That's what's possible. The possible outcomes are only these. And that is 30. So you're right about that. But what you want can only come from that group. You can only pick from the 10, and the 5, and the 5. Because those are the only people we're going to ask, is people that like apples. So then liking carrots would be these two out of those. So therefore, 10 out of 30. Raise your hand if you had that one right. Sweet. Okay. On the test, I would not want you to write 1/3. I would want you to write 0.333 because that's 3 decimal places. Yes?
Should we do the repeating sign above the 3?
No, when they ask you to give you 3 decimal places, they're saying, we know it might go on, but you're only supposed to give these, and then if this number is smaller than a 5, you cut it off. No repeating symbol. Yes?
If there are some questions that don't say the decimal thing, what should we do?
The problems are going to say on the whole test, round it to 3 decimal places.
Okay, thank you.
Okay. One more given one, because those are the toughest kind. Given they do not like apples, what's the probability they like carrots? So I'm just changing the question to given not apples, what's the probability they like carrots? Think about what's possible. What are the only ones possible when they go down on the bottom? Well, the other one added up to 30, so do you get this one will add up to 70? Does that make sense, kind of? Because the people that liked apples was 30 people, so then the people that don't like apples must be 70. And if you're not sure why that is, it's because it's all of these. And if you just try adding them together, those are people that don't like apples. And if you add them all together, you'll get 70. Then, what I want can only come from the ones I circled. So, of the ones I circled, which ones like carrots? Do these like carrots? Yeah, they're in the carrot circle. Do these like carrots? Yeah, they're in the carrot circle. So, those two together would make 40. Process that. Final answer was 40 out of 70. How many of you would have had that one right? All right, that's still a fair number of you. Okay, these problems are tough. And now I want to give you a fair amount of time to ask me questions, so we have a little review, like almost like a practice test that is posted in Schoology, and then there's an answer key for it. And I want you to be able to come up and ask me if you get stuck on certain problems. And you definitely want a calculator for this, so remind yourself however you do that, right on the back of your hand, or put a reminder in your iPad for 6 a.m. tomorrow. Bring calc. Calculators are allowed. And that's all I have for you for the review for tomorrow.